It is so important to fertilize your seedlings properly. Too little, you'll get small plants. Too much, you could actually kill them.
Now, I don't know anything about fertilizing plants at all. He knows a lot, and so in this video, I'm going to ask him questions you may have about fertilizing, and he knows how to get huge plants in fewer than 6 weeks.
You're going to be amazed at how easy it is, so let's get right to it.
So just like in our previous videos, this type will also be a question and answer format.
And also as a bonus, I'm gonna look around the seed starting room and show you what we've started already so people who are following along can see the progress we've made so far in 2025.
All right, first question is, when do we start fertilizing our seedlings and how old are they?
You don't start right away. So when we plant the seed, initially we are going to wet the seed starting medium with water, and you don't need any fertilizer there. The reason is the seed itself has stored nutrients, and that allows it to get to about the true leaf stage.
Which is not the cotyledon stage.
Yeah, so those cotyledons, those are those little leaves that come out. There's 2 of them. They look different than the other leaves, and then the next leaves that come are the true leaf stage. That's about the time when you need to start fertilizing. It's usually about 1 to 2 weeks after you start the seed, but it depends on the type of plant.
All right, question number 2. We start fertilizing about 1 to 2 weeks after germination. How much fertilizer do we use?
Well, that's basically the gist of the video, and I'll tell you it's not what the manufacturers say. Okay. We have found doing a very dilute fertilizer with every watering is the best way to fertilize your seedlings. And that's different because most of the manufacturers will say, you know, fertilize every 2 weeks or something. And I'm going to show you exactly how to do that in this video.
Okay, so question number 3 is we want a dilute fertilizer, but how do I dilute it?
So you're going to dilute it to 50 parts per million of the nitrogen component, and I'm sure that does not make any sense for the most part, but that's really what this video is about. We're going to basically explain exactly how to do that. You're really just going to look at the nitrogen component, and you're going to dilute it very, very dilute, and use that fertilizer at every watering.
So question number 4 is how do I figure out how much nitrogen is in the fertilizer anyway?
So on the label, you usually see 3 numbers, and those numbers correspond to NPK, or nitrogen, phosphorus, potassium. And usually those numbers are going to be somewhere between 1 and 50, and they correspond to the percentage of the fertilizer that is those nutrients.
Do they add up to 100%?
They don't. Okay. So they're not going to add up to 100% because there's other stuff in the fertilizer that are non-nutritive. In fact, organic fertilizers will usually be very low numbers. So it might be something like a 511, which is a fish fertilizer, that only adds up to 7%. That means 93% of that is other stuff.
It's like growing medium or whatever.
Whereas non-organic fertilizers tend to have higher numbers because most of it is actually fertilizer. But let's say you had something like a 10-10-10 fertilizer. What does that mean then?
30%, right?
30% of it is the combination of the nitrogen, phosphorus, and potassium, but how much is nitrogen?
10%.
10%. There you go.
Got a little stressed there. Don't put me on the spot. All right, this is kind of question 4.5. Why do we only use nitrogen when figuring out how to dilute it?
The main reason is that in the seedling phase, nitrogen is the most important nutrient. The other nutrients are somewhat important in root growth, which would be important for seedlings, but a lot of it is when they're flowering and fruiting. And so you just want to use the nitrogen when figuring out what the dilution is. The only caveat there is you do want some of the potassium and phosphorus. So the only thing I would shy away from is a synthetic fertilizer like urea, which is only nitrogen. As long as there's some potassium and phosphorus, it's going to be enough for the seedlings.
Question number 5. It's somewhat confusing to me. How do you dilute it?
So we want to dilute to 50 parts per million of the nitrogen component. This gets really confusing. I promise at the end I'm going to have exact recipes of how to do this, so even if you just don't want to learn the science of it, you can just follow those recipes. But I think it is important to know kind of why we do it. So a part per million is just convention for something that's really dilute. 1 part per million is basically a milligram of solute in a liter of water.
Okay.
So a really small amount of fertilizer in a liter of water. We'll convert to imperial measurements afterwards. We want to dilute our fertilizer to 50 parts per million of the nitrogen component.
So does that mean it's just 50 milligrams in a liter?
Perfect. So it'd be 50 milligrams in a liter. Now that you do have to make one more calculation, and that is because in the fertilizer, not all of it is nitrogen. So let's go back to a 10-10-10 fertilizer, which is what percentage nitrogen?
10.
10%, great. So if we need 50 milligrams of nitrogen, we actually need 500 milligrams of the 10-10-10 fertilizer because only 10% of it is nitrogen. So you need 10 times as much of the fertilizer to get the nitrogen component. Like I said, I'm going to put up recipes at the end so it will make sense.
Now we have our diluted fertilizer. How do we use it and how frequently should we water our plants with it?
So that's the beauty of the system. It sounds confusing so far, but I swear it's not confusing. Once you make your dilute fertilizer, you're just going to follow a recipe. At that point, it's totally foolproof. You are going to use that fertilizer to water your plants every single time you water. So the reason this is so great is it's self-correcting. You don't need to think about giving more fertilizer as they mature or things like that. Because what will happen is when you have a really little plant, so these onions right here, they're kind of medium sized now, they're going to uptake a certain amount of water and, in this case, nutrients at the same time. And I'm not going to re-water this until that plant has taken up all of that water. And so as it grows, you're going to water more frequently because there'll be more roots. It'll start taking up more water, which means you're automatically going to be fertilizing more frequency. So once you make the dilute solution, that's it. You just water your plants.
All right, a big question. What about organic versus non-organic fertilizers?
So both work fine, and it's really just preference of the grower. The main thing is that there's really nothing wrong with non-organic fertilizers. I think there's a lot of misconceptions about that. The actual molecules that the plants use to grow are exactly the same in organic versus non-organic. The difference is in the non-organic, they're sort of already in that shape. Those molecules are just sort of floating around in there. Whereas in organic, it takes a little bit of breakdown in order to release those nutrients. Now, long term, you can have problems using non-organic fertilizers. Basically, a buildup of salts, it can sort of acidify the soil. That can be a little bit harmful to beneficial soil microbes. And also, it can cause increased breakdown of the carbon in your soil. So basically losing organic matter over time. So outside, we use organic fertilizers. Indoors, it doesn't matter. I mean, this is a totally artificial setting.
Completely
We're not creating a, balanced soil ecosystem in a 3-inch pot. So it does not matter whether you use organic or non-organic. We use non-organic mostly, and I have both, and we'll be able to show you. It's really just convenience for 2 reasons. One is the organic ones are stinky. And what's right upstairs?
Our kitchen.
Yeah, our kitchen's right above us. So we don't really want this room to smell bad. And also, once you mix the organic fertilizer, if you don't use all of it, it kind of festers in here. It gets really gross. So you really should use all of it. And it's hard to calculate exactly how much you need. Whereas the non-organic, I usually just mix it into a jug and I just leave it down here. Use it the next day, a day after. It doesn't really get stinky.
Okay, so you keep saying you're going to give some exact recipes for the fertilizer. What are they?
Let's go through some really common ones. So the ones I'm going to go through would be a synthetic 20-20-20. It's a somewhat common fertilizer you can get. And then we'll do Miracle Grow, probably the most common synthetic fertilizer you can get. And then we'll also do AgroThrive. It's an organic fertilizer that I really like, but again, mostly use outdoors rather than indoors. And the other probably most common organic fertilizer is a Alaska fish emulsion. So I'm going to go through all of those. While I'm talking about them, I'll put the actual calculations on the screen so you can kind of see. But again, if you just want to write down the recipes, that's perfectly fine. For AgroThrive, it's a 3-3-2 fertilizer, so it's 3% nitrogen. Remember, the organic fertilizers are generally less percentage nitrogen. For a 50 part per million nitrogen, we need 50 milligrams per liter. So if we do the calculations, we're going to need 1,667 milligrams of AgroThrive per liter. In gallons, we just need to multiply that by 4, so we get somewhere around 6,700 milligrams. One thing nice about the metric system, 1 gram of liquid is generally about a milliliter, so 6.7 grams is 6.7 milliliters, or about 1 1/3 teaspoon per gallon of AgroThrive. For Alaska fish fertilizer, it's a 5-1-1, so it's 5% nitrogen. Doing our calculations, we are going to come up with about 4,000 milligrams per gallon. That's 4 grams or 4 milliliters, which is about 3/4 of a teaspoon of Alaska fish fertilizer per gallon to make our 50 part per million mixture. For a 20-20-20 fertilizer, remember that's 20% nitrogen. So if our goal is to have 50 milligrams of nitrogen per liter, but out of 100 milligrams of fertilizer, only 20 milligrams is nitrogen, then we can also just calculate that there are 4 liters in a gallon. That means we need about 1,000 milligrams of fertilizer per gallon. 1,000 milligrams is also a gram, which is about 1/4 teaspoon per gallon of 20-20-20 fertilizer. All right, last one, which is what we've been using this season. We're just going to talk about Miracle Grow. Miracle Grow is a 24-8-16, so it's 24% nitrogen. And I'm actually going to calculate this in 3 gallons because that's how big our watering jugs are. So in this case, for every 100 milligrams of fertilizer, we get 24 milligrams of nitrogen. 3 gallons is equal to about 10 liters. So we need 500 milligrams nitrogen in the 3 gallons, or the 10 liters. 500 milligrams of nitrogen for every 100 milligrams of fertilizer, we get 24 milligrams of nitrogen, and that's a little over 2,000 milligrams, or 2 grams. 4 grams is a teaspoon, 1/2 teaspoon per 3 gallons. So I know that was a lot of explanation just to come up with some recipes that are really easy to follow, but I wanted you to know why we do it and not just how to do it. And just to show you physically what's going on, here's a little bit of Miracle Grow. Often comes with this little measuring device, and this is a 1/2 teaspoon here. So I'm basically going to take a 1/2 teaspoon of that. This is my 3 gallon bucket. I'll fill that all the way up, put my 1/2 teaspoon in there, mix it around. Nice thing about the synthetic fertilizer, it doesn't get stinky. So I basically just leave this in my seed starting room, and I use this for every watering for seedlings that are past the true leaf phase, which is usually about 1 to 2 weeks old. All right, I promised you guys a little tour of what we've started so far. My plant buddy's here taking a nap, but let me show you what we've got going on. So the onions, this is kind of how those are doing. These are the ones that we potted up into the 72 cell trays. One of the questions we've had in the pictures is kind of what is this? Those are rice hulls. So they're just the outer shell of a rice. It's just a little mulch. You can use vermiculite as well, but we wanted to try that this year. These ones I did give a haircut already. These are the Ailsa Craig onions. We really want to grow huge onions with these, so I put them in bigger containers. Kind of excited about these here. These are little micro dwarf tomatoes. Look at all those tomatoes on there. Isn't that amazing? So I think this one's starting to blush right there. It's really snowy outside, so we wanted something fun to have in the wintertime. And then the most recent video we did was the brassicas. Most of them have yet to germinate. They're just in these to-go containers. But we did see this morning, we're getting some little guys germinated. This is the pak choi. One thing you might find is you might have some germinate, but not all of them. So if you can kind of see in there, there's one in there, but the others are just starting to germinate. I'm fine leaving the humidity dome for another day or so on that to allow the rest of those to germinate.
Well, the camera ran out of batteries.
So we just have a selfie here, but thanks for watching that. I hope that made sense. I know it was a lot of math in there, but again, I wanted to show you guys why we do it that way and not just how. But you can always follow those recipes that we have. Again, thanks for all the support. We've had a lot of new subscribers and we're really happy to have you guys along. If you got this far and you're not a subscriber, go ahead and consider subscribing. We'd love to have you. And if there are any questions we had, leave them in the comments. We're happy to answer them. Happy gardening.